Welcome to our workshop on high performance computing. My name is Avendaño-Franco, and on this video we will talk about environment modules. Before we understand what environment modules this tool is doing for us, it's important to understand three concepts: local variables, environment variables, and shell variables. So in this video, what I will be doing is I will explain each one of those, and we will see a short demonstration on the terminal, and we will discuss the next one. So local variables. Local variables are variables that you can declare on the shell, and they survive for the life of that terminal, of that shell. And they are not visible by programs that you launch from the shell, so of subshell. So if you execute a script or a program, that program is not able to see those variables. So let's demonstrate that directly right now on the terminal. So here I am on the terminal. Right now I am on introduction HPC data, the repository where I have all the demonstrations, examples for this, and you know how to download this is on the description of the website on setup. So let's see what we have here. So I have a few files. We will be working with them in a minute. So let's start with local variables. I can declare a variable like this on the shell. So the shell is like an entire programming language, actually, and we will see that later. So we can declare variables here. No problem about that. And there is, for example, one program that is this, that is able to compute operations with variables, for example. And the way you express the content of a variable is adding the $sign in front of it. So what we are doing is the shell will replace this $A by the content of the variable A, that is 3, and $B by the content of the variable B, that is again 3. So if you execute this, you get 6. And you can override variables, and there is no big deal with this. So now I have the variable b equal to 4, and I can compute this, for example, with and this time I need to escape this star, so the shell doesn't interpret the star. Let's try to expand all the meaning of the star, means all the files on that location. So I will be doing the multiplication of that. So you see 3 times 4, now b is equal to 4, and we get the result. Those are those are local variables. They only exist during this shell. And for showing you what I mean by that, I have here on a script sum that is basically taking a variable a, is taking a variable b, and they are supposed to be there, but we will see, and creating a variable c, that is the addition of a and b. After that is showing the content of the variables, of the variable c. So this is a small script. We will be learning about shell scripting later in the series of episodes of the lesson. So let's see what happens when we execute this script. Notice that we get an error. For this shell, for this script, A doesn't have any value, B doesn't have any value. So of course it cannot compute C, because both B and A and B doesn't exist for them, for the shell. They are not able to see those variables, and it can simply not compute the addition of that. So that's the reason why you can see all local variables, the only existence is on this shell and not subshell. So when you are running this script, you are creating a subshell. So now the next here are environment variables. So environment variables, consider about them like global variables. They can be used by the shell, but their scope is much bigger. So subshells or programs that use launch from that shell are also able to see those variables. Let's return to our terminal demonstration, and here we have so we know that A, and we can let's go back. A has an existence here. Same thing for B, but right now they are just local variables. So we can promote them into global variables or environment variables with the command export. And so with this, nothing has changed from the point of view of this command. A continues to be A and B continues to be B. But now what happens when I run this script? Now A has a value that this sum.sh is able to see, and B has a value that is also visible, and of course you can compute the sum and you can see the result. So now at this moment A and B are environment variables. They are global variables. You can use them inside your program. There is a way of removing those variables is with the command onset. So we can undo this with this way, and we execute again, and you notice that those variables doesn't exist anymore. So another way to contour this issue with the local variables is doing something like this. For example, b equal to 4 and executing the script on the same line. So all those variables belong to the same subshell, so they are captured and as variables for the script, and they will be able to execute or to operate with them. If you don't want to do this, the other option is exporting those variables, so they will be promoted as environment variables. So now, a third concept here, shell variables. Shell variables can be either local variables or environment variables. The difference with them is that the shell uses those variables for various purposes. So if you don't know what you are doing, it's better not to change their value. And we will see a few of them. So every single time that you log into the cluster on your terminal, you have a bunch of them already created for you. So let's go back our terminal demonstration, and let me clean this now I'm here, and the command env will show me all the environment variables, and some of them, and most of them are shell variables. So for example, this one, home, is the location of my home folder. So I can write something like this, and this is my home folder. So this variable always receives the content on the location where I'm supposed to land when I'm logging into this machine. That is my home folder. Another important command should be around here. Sometimes let me see, let's go to copy mode so I can search for it. This one is a big one. This one, this big variable contains the locations of all places where this shell will start looking for executables. So, and they will search for executors on the order that this variable describes them. So the first we will try in this Purge, bean, opt torg, a number of them, looking for the variables that I would like, for the executables that I need to use. So this is an important variable for the shell. Another important variable here, the host name, for example, is extremely important. So this variable contains the name of the machine where I'm working. This is my default shell. This variable here is my current location, pwd. So this variable changes, so I can execute this, and it will tell me that I'm on this location, but I also can do this. And we'll do exactly the same. This variable indicates where I am currently, which is my working directory at this moment. So you see there are a number of variables. Those that I just described to you are variables that are important for a show. So if you don't know what they are, do not change them. Unexpected results can happen if you change those variables. So now let's move into environment variables. Now we are ready to discuss what this environment modules is. This is a tool. It's a package that you can install on a computer. It's particularly useful on an HPC cluster because, as you know, many people is using the cluster. People from different domains, different research interests, and they use different software all the time. So we have people in chemistry, physics, biology, health science, engineering. All of them are use different software, and sometimes different versions of the same software. So we need to accommodate the needs of different people and the progress that they need. And one solution for that is having this system. So consider this system like a set of pull handles that allow you to change dynamically the shell variables in particular that you need to be able to access different programs and the libraries associated to them and get access to particular software, compilers, special libraries, numerical libraries, all sorts of things. So the most common variables that we change when you load the module or unload the module are those. Path, for example, if you have an executable for a program, this location will be added to your path, and loading module will put that location on your path. Unloading the module will remove that location from your path. So this is a dynamic process when you can load and unload modules. LD library path, some executables contain their functionality on separate libraries. They are linked during runtime, so you need the location for those dynamic libraries in order to be visible when you execute the program. So all those adjustments are done behind curtains when you are loading the module. So let's go back to our terminal demonstration and we will see that more clearly. Notice that on the right side of the video you will see a few commands that we will be using here from the module package. So we will be learning just 4, and this is pretty much enough for most purposes. So the first one is module avail. You want to see which software is available on the cluster. Execute this command. Let's go into copy mode here on my tmux session. You can go up and see all the modules that I have created for you, because at some point you need it, or at some point someone make a request for installing a package. So I installed that package and I create a module for it. So and I organize those modules in categories, in tiers. So, and the first tier that you see right now is what I call tier 0. They are basically compilers for different languages, for C, Java, Julia, Python, all related to languages, programming languages, and libraries for fast Fourier transforms, for linear algebra, for different purposes in scientific computing. So also libraries for data management, like NetCDF, HD5 for managing big binary files. All those modules are here. Also for parallelism, for different ways of running the code in parallel. So they are here. In the next tier, I have Conda, that is an environment utility that we will eventually see later on this set of episodes. MATLAB, that is a package for programming from user-friendly interface, and Singularity, that we will see also this package, that they are basically creating their own environment. So they are a very special software in that regard. And now in the next tier are actually the software that you probably actually need. So very specific packages for different domains in science, astronomy, and several packages here for physics and chemistry. Atomistic simulations, a few packages in bioinformatics, packages for mathematics and visualization. So, and finally, I have a few meta packages. There are easy modules for loading a bunch of other packages in just one command for people who don't want to worry too much in loading too many modules. So they can load just one and they will get a comprehensive setup of software, languages, and libraries. So those are all the modules that I have. So now let's see the importance of that on a very practical example. So I have here code. Let's see this code very briefly. So this is a very small code written in C++. And there is nothing particularly complicated here. It's just that this code is using a few commands, a few instructions that are from the C++ language specification from 2014. That's the only particularity of this small program. So what I will be doing right now is trying to compile this software. The operating system came with its own compiler, GCC, and we can see the version of this compiler. So right now we have the GCC compiler version 4.8, the version that came with the latest version of Red Hat. So this cluster is running Red Hat 7.6, and this compiler in particular is 4.8. Same thing will happen if we try to see the version for the C++ compiler. So now let's try to compile this code. So G++ lambda, and let's create as an executable lambda C++ 14. Let's see what happens. So now you get an error, and the reason of this error is that this compiler version 4.8 is not capable of compiling codes for this specification C++ 2014. This compiler is older than that. So you cannot compile this code with this. Now, what we can do is to load the module for languages GCC and this version, for example, 9.3. Now, we have now a different version of the compiler. GCC is 9.3. What we have done is we have overimposed a different location for searching executables, and now this GCC takes precedence over the Red Hat compiler. And this version of GCC, and of course G++, the C++ compiler, is capable of compiling the code. Now let's try it. So I can re-execute this command, same command. Now this time G++ is going to a different executable. And now we have no issue compiling this code. See, no message, no error. This code has been compiled. And we can now execute it. This code now works. Notice for the compiler, changing the compiler can make the difference between being able to compile a code and get a failure, an error in trying to do so. Some people develop code on the leading edge. They need certain advantages of new languages, new specifications, so they try to use those capabilities. And sometimes the compiler that came with the operating system, Red Hat, that is an operating system for industries, they try to be very conservative when for the selection of the packages. So they are always several years back in versions. So research from the other side is a completely different story. We want the latest and best packages, software. So we like to have a good balance between having something that is new, but something that is stable, or at least is able to produce good science. So now with this, we can load the modules that we need and compile the code. Now let's do another example here. So I have this code. Let's have a look at this other code. And we will be learning in our next episode how to compile codes. So the idea here is not learning how to compile the codes, but learning how to load the modules. And that happens in these episodes. There is not an easy way to explaining progressively. So I will be explaining you the modules, because we will use the modules for the next episode, that is compiling code. And for compiling code, I'm showing you here how to compile the code. So we are going into recursive operation, but that's okay. So here I have a code. Again, this code is written in C++. And this code is using, notice here, they have a header here for FFTW3. So this code uses a very popular library for fast Fourier transforms. For those of you who know what I'm talking about, those are special ways of manipulating functions. They have some periodicity, and you can do nice things with them. So the important thing with this code requires this library, FFTW3, and at some point is doing some calculation. This is doing a Fourier transform. So right now I have this code, and now let's try to compile this. -O. Okay. And now I get an error. And I get an error because I need this library, and I have not declared this library. For actually using this library, you need to load the module for it. So let's have a look. Module avail, and there is one way of libs here, and you see here that we have a few libraries, a few modules for FFTW version 3.38. So let's load that library. So I already, let's see which modules I have currently on loaded. I have the lang GCC 9.3, so the GCC compiler. So what I need now is to load the module for libs FFTW 3.8 GCC 9.3. So module list will tell me that now I have the library. So I'm capable now to compile this code. For compiling this code, I need to declare here that I would like to use the library FFTW3. And now the code compiles. I can execute this code, and this code doesn't show anything on the screen. It's actually creating a few files. So it's creating an input signal, and it's creating the Fourier transform of that signal, basically showing the frequency or the various frequencies of the signal. So now we have here a code that was compiled with GCC 9.3 and using the fast Fourier transform, the FFTW library. What happens if I purge modules? This command, what it's doing is cleaning all the modules that I currently, unloading all the modules that I currently have. So if you see the list of modules, I have nothing. So GCC now is GCC 4.8. Now, if I try to execute this code, it will fail. And it will fail with a message that some of you have encountered at some point, and you ask me to look into this and solve the issue for you. So it's a good time for you to understand what this message means. This message is saying that this library is not available, and it's not available because you have not loaded the module for it. You need to load this module because this code was compiled dynamically for using that functionality from the libraries that are located somewhere else. So another way to look into this, executing this command. This command will tell you all the dynamic libraries that this code, that this executable requires, and if the code was able to find the library for it, for it or not. So we see that we were able to find all of them except this one. So FFTW3 was not found. So the way of solving this is basically recovering the same environment that we use during compilation. So FFTW3 GCC92. So now if I execute the same command, you will see that several lines have changed. This library here for libffftw3, now it was able to find a location for it. Now before it was using this, probably this is not a big issue, but now it was able to find the actual library that I provide from the GCC 9.3. Same thing for this other library here. So now this code will run without any issue because we have now loaded the modules for it. So this basically tell you the main message for this. So you use modules to get access to codes, libraries, compilers that you need for your research. So module available, for example, And let me search. Okay, this one, for example. Let me see. Use this atomistic module Purge, for example. Module load. And you can use tab if you want to complete this. This is a code for atomistic description of materials. So you can load the code, and now I am able to access this package. Previously, this executable was not visible. And in fact, this module is actually loading several module list. So this package is actually behind curtains loading quite a bunch of modules itself. All those modules were I load them when I compile this code, and I need them for running the code, because in most cases I compile this dynamically, so I need the libraries to be there when you run the code. So this basically completes our story about environment modules, and I hope you now get the idea why we use this, what is important to keep an eye on all the modules available on the system, and also if you see the documentation, there are information about how you can create some modules. So let's see, for example, this module that I just showed here. This command is basically showing you the internals of that module. So if you want to see how that module was created, is this file. It's a file that is declaring, okay, all those environment variables need to be changed in this way and this way and this way. And we need to load a few other packages and other modules for getting access to all functionality that we need for this software. So this is the command that is doing that. So you basically need those 4 commands that I show you on the right side of the screen. Module avail for knowing which modules we have, module load for loading the modules, module unload if you want to unload a specific module, but typically what you want to do is just purge, and if you want to see the module, the content of a module show. And that's basically all that you need to learn. And this is, again, those videos go directly to the point. This is what you need to learn for start being effective on the cluster. So that will be all. Thank you very much. We will see you on our next episode. Bye bye.